Welcome back to the class. Yesterday, we had a brief introduction and we looked at why electric vehicles are starting to become big. And we started by saying that while it fights pollution, it means no oil import, makes a lot of difference for a country like India. We talked about that it also has much less number of moving parts and 4 times higher energy density. And then we pointed out the biggest constraint is the energy density of batteries which contains energy vis-a-vis the petrol tank which contains petrol. And even with 4 times the efficiency, we are still of the ratio of between 7 to 10 times. If I take a battery which is a container of energy, it is probably 10 times heavier for the same range as compared to a petrol tank. And if I look at it volume, it is about 6 to 7 times higher. And we pointed that out and then sort of said the biggest gain is the battery energy density is continuously increasing. It has gone up by about 3 times or more in last 8 to 10 years. We also pointed out that as the energy density increases, the cost is coming down. The cost was the second biggest constraint, the volume, weight and cost, but the cost is also dependent on the energy density. As the energy density improves, the cost comes down. This is what we did and sort of said that well, it is today viable and it is going to become more and more viable. That was the beginning. We then started looking at okay, with that how do you focus on the vehicles, and we start saying let us look at India. And we actually found out that and presented that India actually needs affordable and small vehicles dominated by 2-wheelers, some 3-wheelers and small cars. And we said that these are highly affordable. The cost of Indian vehicles are far less than the vehicles in the West. And if EV has to replace them, they have to be a similar kind of pricing. And this is a very big constraint. World over they are working on larger vehicles, they have got somewhere. Their affordability is not as serious a constraint. So, EVs have taken off. In India, we have to make the small vehicles or 2-wheelers succeed, 3-wheelers succeed, small cars succeed. And we started therefore sort of saying for making them successful, what do we need to do? And we figured out the big problem in that is again the high cost, size and weight of the battery. And we sort of said that what can we do? And we talked about that if we improve the energy efficiency of the vehicle, and energy efficiency of the vehicle can be improved by improving the motors and controllers. If we improve the tires, if we improve the aerodynamics and finally the weight, it helps us improve the energy density. Of course, all these things will add cost, but the savings that we will get in smaller battery is going to by far offset the expenses that we will incur in making the vehicle more efficient. So, the first slogan for India will be, we will ask this question kitna deti hai, and we will make our vehicles very efficient. We then sort of said well, that is not enough, and therefore, we came up with the idea that why can't we use smaller battery rather than larger battery. The world over for larger range you go for larger battery and that increases the cost. We say we reverse it and say we will put a smaller battery, but the smaller battery has smaller range and we said that will cause a serious usability issue, because charging takes time. Charging cannot be done in a few minutes like filling petrol can, and that is the time we came up with the concept of swappable battery. If we swap battery rather than charge them whenever it runs out, we can do that in a few minutes, and we came up with the concept of energy operator who will purchase battery and helps us set up charging cum swapping centers. That will help us a lot, and for a particularly we said for a public vehicles we can get that started. Even for private vehicle, 2-wheeler and 4-wheeler, we can use that as a range extension, use a smaller battery built in plus a small battery which is a range extension. So, we came with a totally different approach. Of course, we can follow the same approach that is followed in the West of just making the battery larger, paying extra, that is possible. So, we talked about these three things. Now, if you see, the key issue therefore has been batteries, and for us to succeed in India with electric vehicles, we have to understand and innovate more and more on batteries. So, this chapter is going to start looking at batteries. This is not a chapter, sorry, this is a part of the introduction. We will introduce the battery. Of course, in detail we will have 2 chapters on batteries later on, but right now let us just introduce the battery. We remember we have been repeatedly pointing out that the capital costs are high. When capital costs are high, how long will the battery last? The life cycle of the battery becomes extremely critical. If the life cycles are small, we have to put that large capital cost again and again and again. If the life cycles are larger, I do not have to invest that on the battery again and again. So, the key parameter, one of the most important parameter is what is the number of charge discharge cycle that a vehicle can support. You may get some number from manufacturer saying 2000 cycles, but then the manufacturer will start putting lots of constraint, because while the charge discharge number of cycles depends on battery chemistry used, and that is done by the manufacturer, it also depends on the rate of charging, how fast are we charging and how fast are we discharging. Rate of charging and discharging plays a very important role. We will see that if we increase the rate of charging, the battery life comes down like anything, and same thing with discharging. We will get into this little more detail. The next important thing is temperature. The batteries, lithium ion batteries best behave at 25 degrees centigrade. If we go below 25 degrees, if you go to 15 it is still okay. If you go to 10, 5 degrees, 0 degrees, battery does not work well first and then does not work at all. Similarly, if we go for 35 degrees, it is okay, it works, it has a little deterioration, not as bad. You go to 40, 45, 50, it works, but the life cycle deteriorates like anything. Now, remember it is a large capital cost and we are depending that it will last long. Now, it will not last long, and unfortunately, India very often the temperature is above 35 degrees centigrade, 40, 45 is not on that common, even 50 we hit upon that. What happens to the battery? Is the life cycle going to severely get impacted? And the third thing is what is called depth of discharge. We will look into that little bit more in detail. But do we charge battery full or do we empty battery completely? If we empty battery completely or charge it to 100%, it does not work well. What we will figure out is that we have to charge up to certain percentage and not above that, and we have to discharge up to certain percentage, that is called depth of discharge. that is going to be another parameter which will impact the life cycles like anything. And finally, calendar life. If you do not do any of these things, but still keep the battery, it deteriorates, small amount, but does deteriorate. 4-5 years calendar life deterioration is not that bad. Beyond that starts deteriorating. If you do 10 years, yes, it is a serious problem. So, we will look at that. This is a very important parameter that we have to worry about is what is called state of health of a battery. When there is a new battery, state of health is very good. As we start using it, the capacity that we have starts declining. As more and more number of cycles are used, you will see its capacity keeps on declining. And the capacity at any time is called state of health. It is a measure of capacity that is present at any time. It started with a capacity C, but it has gone down. Why is it so important? Because if the capacity declines to, let us say, 80%, what does it mean? That we started with a battery of certain size, it gave me so many kilometers of range. Now, it is giving you only 80% of that range. A user will not like it. It was giving me 90%, was okay. By the time it comes to 80%, it was giving me 100 kilometer, now it only gives me 80 kilometer. My anxiety will increase, and generally I will say, well, at this point of time, I like to replace the battery. That is called end of life of the battery. End of life EOL of the battery in a vehicle. Now, I may choose that no, I can continue to drive it, but maybe 75% will be the end of life, or maybe 70% will be the end of life. I can choose whatever. It basically means what compromise am I willing to make as a user in terms of range. But there is always an end of life, typically 80%, sometimes 75%, in some situation even 70%. So, if battery reaches its end of life, you no longer use it, you have to replace it. So, the life cycles that really matters to us is only from a new battery to the end of life. When state of health reaches that terminal point, you will say, well, battery's life cycle has been used. As has been pointing out, the battery life also is significantly dependent on rate of charge, and lithium ion battery is best charged slowly. If you charge in 5 hours, 6 hours, it gives you very good life. You charge in 4 hours, it gives you decent life. 3 hours, slightly worse. 2 hours, slightly worse life. If you start charging faster than 2 hours, you will see the number of cycles that it can support keeps going down. So, there is a concept of what is called slow charge, and there is a fast charge. Slow charge is typically 3 to 5 hours, sometimes 2 hours. Fast charge is 1 hour or less. The fast charge impacts battery life. That is the first important thing that we must remember. So, for example, typical battery life for a new cells, new battery, when it comes out of the factory, could be 500 to 2000 cycles. These are 500 to 1000, the battery life can be anywhere from 500 to 2000 cycles. For example, those with our batteries which are 500 to 1000 cycles cost low. If you are looking at 1500 to 2000 cycle, will cost slightly higher, medium costs. If you are looking at 3000 to 4000 cycles, the cost will become very high. So, general, and then on top of it, if you do not want the life to deteriorate when it is charged fast, the cost becomes even higher. So, the battery cost, while we talked about the target being $100 per kilowatt hour, that is a cell cost, that is only for something medium. If you want fast charge, then cost goes up like anything. If you want more life cycles, cost goes up. So, you must always understand the rate of your charging and discharging in figuring out what the life cycles are. An important question that one asks is how many cycles does one need? It depends on distance that one can travel with the battery in one cycle, and also depends on what is the total distance that we expect to travel in the lifetime. For example, suppose there is a battery which travels, which enables you to travel 600 kilometers, and you are there in a car. And suppose the life cycle is 1000 cycle, you can travel 600,000 kilometers. That is not bad at all, because a car is unlikely to last beyond 600,000 kilometers. So, a 600 kilometer range battery, 1000 cycles is more than enough. On the other hand, if I have a battery in a vehicle which gives you only 100 kilometer range, if I have only 1000 cycle, it will only give you 100,000 kilometer. A vehicle is expected to go long higher than that. So, you will probably need more like 2000 cycles. So, it gives you 200,000 kilometers, that may be acceptable, you will support it, you will replace it, or maybe the vehicle itself will be worn out. Similarly, for example, if you have a scooter and suppose you have a battery of 50 kilometers, and suppose there is a 1500 cycles, then I should be able to use it for 75,000 kilometers, which for a scooter is not bad. So, what is the size of the battery and what is the number of cycles that you need will depend on your usage. Similarly, sometimes people say I have a 600 kilometer battery, for example, that is a typical size of a battery in a Tesla car, and if I fast charge it at 1 C, we will come to the definition of 1 C, it takes 45 minutes. Now, if it takes 45 minutes to charge fully, how much fully is 600 kilometers? How much time will it take to charge for 150 kilometers? 1/4 of that, and that is only about 12 minutes or so. So, if I have the ability to do fast charge in about 45 minutes to an hour, actually I can charge only for 12 minutes to 15 minutes and still get 150 kilometer range. But this is provided the battery itself is 600 kilometer range. Sometime in advertisement etcetera it comes, or you can charge it in 15 minutes or 12 minutes, you can do so, provided ahead right in the beginning the battery is large and supports 600 kilometers, and therefore, it is extremely expensive, and you can charge for 12 minutes and 15 minutes you can get 150 kilometers. But suppose my vehicle, I have an electric vehicle, it has a 100 kilometer range. Now, if I can fast charge it in about 45 minutes to an hour, 45 minutes. In 12 minutes therefore, I can only charge about 25 kilometers. Now, 25 kilometer, if I sit down and spend an hour, I spend about 15 minutes and charge 25 kilometer, it does not give me much. 150 kilometer is a lot. If I have somewhere, if I am going and I am still not reached my hometown, I still need to drive. I can stop for 15 minutes, charge, take another 150 kilometer, which may be good enough, but not for a small car with 100 kilometer range of battery. So, this is important, because very often the advertisement is misleading. It says in 12 minutes I can charge for 150 kilometers. Sure, if your battery is 600 kilometer and if you have paid fortune for that. So, there is a assignment problem that I want you to do, and this is that suppose you take a 2 kilowatt battery and sub-hour battery, and it costs about 30,000 rupees. Suppose the purchase is made borrowing money from the car, borrowing money. So, here is my third assignment problem, home assignment 3. What we are trying to do is, remember that at a point of time we had said that we would like to figure out what is the effective cost of usage of a battery. So, this assignment problem is the first problem towards that. Suppose I purchase a 2 kilowatt hour battery and it costs about 30,000 rupees, and suppose I borrow money to purchase this, and I have an interest payment of 12%. Suppose battery is charged about 1800 cycles. This is a lifetime over which it has to be depreciated. The question is, compute interest and depreciation payment per year. We will find later on that if you do this using Excel, there is a function called PMT which does this, interest and depreciation payment. What we will do is that we will estimate that. We are not going to use spreadsheet right now. Assume that electricity costs 5 rupees per kilowatt hour. Battery depth of discharge is 0.85. So, I can use only 85% of the battery at any time. Suppose we assume vehicle uses 20 watt hour per kilometer, something like a two-wheeler. What is the fuel cost per kilometer? Remember what I have to do? I am buying the battery at 30,000 rupees and I am going to use it over 1825 cycles. Let us also assume here, which I have not, that it is charge discharge once a day. So, basically I have 1825 days. How do you estimate this PMT? You estimate, this is a very formula, just use this, later on we will figure out what it is, that you first estimate what is called A, calculate what is A, which is interest rate, number of unit time, for example, in this case 1825 days, and what is the capital cost 30,000 rupees divided by 1.55. You compute this A. Why does this 1.55 comes? Is leave it now, later on when you do PMT you will understand that better. And next you find out the payment that needs to be done every year is equal to the cap A, this quantity that you calculated, plus the capital cost divided by number of unit of time. Number of unit of time is 1825 days, you can convert it into years. This is a problem that I want to give you. Please try to solve this. You will get how much is the cost per kilowatt hour. We have said that how much is a battery charge discharge once a day. That is an important parameter thing that was missing. I will add that, and vehicle uses 20 watt hour per kilometer. So, vehicle every day will travel a certain distance. So, you can figure out the total cost of the battery for a year, also figure out what is the total travel for the vehicle in a year, and from there you can compute what is the fuel cost per kilometer. Okay. Please try to solve this problem, it will take a little effort, but you will learn a lot in this process.